this is where the first confusing name might come in, the DBS. It is a backscatter detector. It is a Thermo Scientific detector that's found on both of the covalent microscopes. It functions as a single segment backscatter detector that slides underneath the pole piece. And what it gives you is atomic contrast. The Everhart-Thornley image on the left side, we can see the silicon has been etched. There's some relief along the edge, kind of like a mountain range here. And then we can see some diffraction contrast in the crystal and silicon. Gives us a very different bit of information than we see on the right side, where this incomplete solar cell was processed to have a silver trace here, and then the etched silicon. So the silver, very bright, high atomic number, the silicon darker, low atomic number. This also looks flat, and backscatter images are often flat looking because the signal is coming straight out of the sample and going back up towards the pole piece at a high energy. And so a lot of the topographic information is lost. When you take that DBS detector, the directional backscatter gets its name because it's segmented and it has a number of concentric rings that can be used in something called concentric backscatter mode. If you take the center ring, you're going to get the highest angle, lowest energy loss backscatter electrons. That's going to give you the best backscatter image. And we can see segment A there, very distinctive, better backscatter image than I had even on the previous slide. The silicon is super dark, the silver is nice and bright. Material that's on the surface of the silver really stands out. When I use the D segment, pushing it out to the side, you can see topography really jumps out. Again, still backscatter, but it's the lower angle backscatter, and it's going to contain more topographic information.